In addition to familiar value types, such as integers and strings, MongoDB includes native support for geospatial data. This functionality supports applications that require the ability to calculate distances between locations, or to identify all locations within a specified distance from a starting point. This is all done natively within MongoDB based on built-in support for common geospatial data formats, geospatial indexes, and algorithms supporting a variety of operations on geospatial data. For geospatial fields, Compass provides some valuable tools for exploring data in the schema view. We can also filter a collection based on geospatial values by specifying a center point and radius in which matching documents must fall. Let's take a look at this collection. It's found in the ships.shipwrecks namespace. Rather than a bar graph depicting the distribution of values, as we see for int32 or double values, for geospatial data, Compass shows us a map widget with pan-zoom capabilities. Looking at the coordinates field in this collection, we see that Compass provides a map depicting data points for the coordinates of each shipwreck found in this collection, provided the coordinates field has a geospatial value. Let's zoom in and pan to the southeast of the United States. You should be able to do this using the controls you are accustomed to using for those actions on your own computer. I'd like to center in on the island of Puerto Rico. Now, as you can see from our summary collection stats, just below the filter form field here in Compass, we're currently looking at summary data for 11,095 documents, based on a sample of 1,000 documents. For this collection, what if we want to filter just for shipwrecks off the coast of Puerto Rico? For int32 or double values, we can simply click on a bar graph and drag. For geospatial data, we can do something similar. We can identify a center point, hold the Shift button, and then drag to a radius that encompasses the entire island, plus a little ways off the coast, as we've done here. We're just eyeballing here, but this is a great way to explore a dataset to get a feel for more precise queries you may need to run. If we look at the filter form field, we see that Compass has created what might at first look like a pretty complex filter document. Now, a detailed discussion of geospatial queries is beyond the scope of this lesson, but for now I'll simply say that as with the $GTE and $LT operators for range queries, the GeoWithin operator, applied to the coordinates field for documents in this collection, allows us to filter for all coordinates that fall within the geometry we specify as the value for the GeoWithin operator. In this case, our geometry is a sphere for which we specify the center point and the radius. The center point here is the point I clicked. The radius here is measured in radians. It's pretty straightforward to convert between miles or kilometers and radians. See the lecture notes for a link to documentation that describes how to convert among these units. You can use this information to determine how to edit the filter documents to specify a radius in precisely the units of interest for situations in which that's helpful. Now, if we apply the filter we've created, you should see that the number of documents matching the filter is 99. You should also see that having applied this filter rather than a sample, Compass has retrieved exactly the 99 documents matching our query. As a consequence, we see several additional dots appear on our map, all of these here along the coast. One for each of the coordinate values of each shipwreck document matching our filter. This is one of my favorite features of Compass, I suppose because it's exactly what you should be able to do in a UI such as this. In other lessons, we explore geospatial queries in much greater detail. That's how you use Compass to explore and filter geospatial data.